All right, so 2.6, now what we're going to do is we're going to start solving using log functions. So we're going to start out easy. So if you had log base 5 of x equals 2. So again, remember the rearranging. If you ever are working with logs and you aren't sure what it's asking for, just go ahead and rearrange it. Make it into an exponential function. So this is my base. This is the exponent. My x is the total. Okay, so 5 raised to the second power gives me what? So 5 raised to the second power is 25. So my x equals 25. If we're working with a common log, okay, so common log 1,000. So what this is saying, you can rearrange it. Remember, when there's no exponent or when there's no base, it's base 10 because it's common log. So 10 raised to what power gives me 1,000? Okay, so 10 raised to what power gives me 1,000? So we can go back to, if I were to rewrite this with base 10, it would be 10 to the third power. Okay, so x equals 3. So this goes back to when your base is the same, the exponents are equal to each other. All right, so now what we're going to do is we're going to expand on this a little bit. And I want you to solve the following equation. So log base b of x is, I'm going to start out a little bit easier on you, plus log base b of x plus 2 equals 0. Okay? So this goes back to our properties of logs. When you see a plus sign and you're dealing with logs, remember that plus sign means you're multiplying. So what we're going to do is we're going to condense this down and we're going to write it as log base b. So when I see a plus sign, I'm actually multiplying these two things. Okay? So what this says, now I can rearrange it into an exponential function. B raised to the 0 power equals x times x plus 2. Okay? So anything raised to the 0 power is 1. I'm going to distribute. So x squared plus 2x. Okay. And now I'm going to move my 1 over. So I have x squared plus 2x minus 1 equals 0. And now I can either use the quadratic formula or I can factor if I can factor. But the only way to get negative, a negative product, is one has to be negative, one has to be positive. So with factoring, in this particular case, it's not going to work because the only way to get negative 1 is negative 1 and positive 1. That does not add to 2. So the factoring won't work. So with this one, what I have to do is I have to use my quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And now I just simplify it. Negative 2 plus or minus 4 plus 4 all over 2. So I get negative 2 plus or minus the square root of 8 over 2. And then to simplify this, I have a 4 times a 2. 4 is a perfect square. So I have negative 2 plus or minus the square root of 4 is 2. This 2 stays underneath the radical all over 2. And then I can simplify. So negative 2 over 2 is negative 1 plus or minus the square root of 2 because 2 over 2 is also 1. Okay, so those are my two values, negative 1 plus or minus square root of 2. If you can't factor, then you can always use the quadratic formula. All right? So let's try another one. All right, how about this one? This one has fractions in it, so we're going to go ahead and do this one. So we have log base b of x equals 2/3 log base b of 125 plus 1/2 log base b of 4 minus log base b of 10. So one thing you want to notice is all of these have log base b. That means we're good to go. We can go ahead and use the properties of logs. So I'm seeing plus here, which means I'm multiplying these two. I'm seeing minus here, which means I'm going to divide by 10. And I have log base b of x. So we can go through and do x equals, because all of the logs are the same, all the bases are the same, now I can just deal with the exponents. So remember, this is 2/3 times, which means this is going to become the exponent on 125. So I have 125 raised to the 2/3 times 4 raised to the 1/2 divided by 10, because it's a minus sign. Okay, now, one thing that we haven't really talked about a whole lot is when you have a fractional exponent. So a fractional exponent is just a root. Okay, so when you have a root, this is your index, this is your radicand, and then we have an exponent on this. Okay, so whenever you change from a radical to a fractional exponent, so let me give you an example. Okay, so I have the cube root of x squared. So the x is my base, the 2 is my numerator, the 3 is my denominator. So the denominator is always the index. It's always the number out here. Okay, so you just rearrange it. So what this is saying, this 125 to the 2/3, that's actually saying the cube root of 125, that answer squared. Okay, so what's the cube root of 125? 5. 5 squared is 25. So this number right here becomes 25. This number, 4 raised to the 1/2, is the same as the square root of 4. So remember, a square root is an assumed 2 here. So there's the 2 there, the 1 there. So square root of 4 is 2, all divided by 10. So 25 times 2 is 50, divided by 10. So my x equals 5. Okay, so what this does is it puts all of those properties of logs together into one function. You have your power rule, exponent on an exponent. You have your product rule. When you see a plus sign, you multiply. And the quotient rule. When you see a minus sign, a minus sign, you're dividing. Okay?